Hey guys, hopefully you're finding these helpful. I would like some feedback if possible. Just let me know if you were able to understand the video and if it was any help. If it's not, then we can consider doing something else, but I feel like this will be an easy way that you can watch again and again and go through and see if you can figure out exactly what's going on each time. So our topic for this web tutorial is percent yield. So when you think of percent yield, you should think of a term like efficiency. So how well something performs to expectations. So the efficiency of a reaction. To find the efficiency of a reaction, we have to do really two things. One, we have to find a predicted value. So predicted value, or we'll call this a theoretical value. So a theoretical value. This means, if everything went 100% according to plan, this is what we would get from our reaction given some set of starting conditions. So we find this predicted or theoretical value using a gram to gram problem for most of the time, because we're usually going to focus on how many grams of a substance was formed. If you need a refresher on how to do a gram to gram problem, check out number 4, the video on mass to mass conversions. That will help us. So we need a predicted value, and then secondly, we need an actual value. So what did the group actually obtain when the reaction occurred? So this is done experimentally. So it's done experimentally. The experiment is done. They collect the data, and then they're going to compare. And to compare, they're going to use our percent yield formula. So our percent yield of a reaction is equal to the actual value. That's the value that's obtained through the experiment over the theoretical. And then times 100%. So we talked about in class, we compared this to free throw percentage. Theoretical, that's how many shots were taken. That's our predicted value. And then the actual is actually how many shots you made. So our goal is we want to have a fairly high percent yield for this for our reaction. So we're going to solve for this in 2 steps. The first is to do a gram to gram conversion, and the second is to use the percent yield formula in order to find our percent yield. So let's look at our problem for this tutorial. It says zinc iodide is produced from the reaction of zinc metal and iodine gas. So I'm going to go ahead and write an equation. I know I'm going to have it. It's always my first step. So zinc metal, if an element's just by itself in an equation, it's just its symbol. So zinc metal reacts with iodine gas. So iodine is diatomic, so it's going to be I2. And that's going to form zinc iodide. So if we look at the periodic table, zinc is a metal, so we're talking about an ionic compound. So we need to look at oxidation numbers of the charge. Zinc is +2, iodine is -1. So when we crisscross those charges, we end up getting a value of ZnI2. For our chemical formula for zinc iodide. Then we need to check to see if it's balanced. I have 1 zinc on this side, I have 1 zinc on that side, it's balanced. 2 iodine, 2 iodine, so we're balanced here. So now we need to start working on our conversion. So my given information is 125 grams of zinc. I need to convert that all the way to iodine. Sorry, not iodine, zinc iodide. In order to convert grams of zinc to moles of zinc, I'm going to divide by the molar mass. If you look on the periodic table, the molar mass of zinc is 65.4 grams. So 65.4 grams of zinc is equal to 1 mole of zinc. Grams of zinc are going to cancel here and here. Now that I have moles, I'm going to use a mole ratio. So the ratio is 1 mole of zinc to 1 mole of zinc iodide. Moles of zinc are again going to cancel here and here. And lastly, I am going to put my conversion back to grams of my needed information, my zinc iodide. So 1 mole of zinc iodide is equal to 319.2 grams of zinc iodide. Moles of zinc iodide cancel here and here. So now it's just left to solve. So it would be 125 grams, or 125 times 1 times 1 times 319.2. And then we're going to divide that by 65.4. And then the ones are not really going to change our answer at all. And we get an answer of 610 for our theoretical yield. So 610 grams of zinc iodide. That is our first step in this problem. And our second step is going to be to use our percent yield formula. In order to do that, I need an actual value. So the second part of our problem says the actual yield, or the actual value, is 515.6 grams. So remember, percent yield is going to be equal to our actual value over our theoretical value times 100%. So my actual value is 515.6 grams. My theoretical value, that's the value that we just solved for on the last page doing the gram to gram conversion. I got 610 grams of zinc iodide for that, so we're going to put that on the bottom, 610 grams, and then we're going to multiply by 100%. So 515.6 divided by 610 times 100% gives me a percent yield of about 84.5%. So 84.5% yield. That's a fairly good percent yield. If you were a basketball player, you'd be happy with shooting 84.5% from the free throw line. It's not the best, but it sure could be a lot worse. So this is our percent yield. If we wanted to find percent error, because remember, percent yield shows us kind of how right we were. Percent error shows us how wrong we were. So we wanted to find percent error. We're going to move on just to the next slide here. So just a reminder, percent error is equal to the absolute value of our actual minus our theoretical. Remember, the absolute value just means we can ignore our negative sign if we get one, divided by the theoretical. And then times 100%. So our actual value was 515.6 grams. We're going to subtract our theoretical, 610 grams. We're going to take the absolute value of that. We're then going to divide by 610 grams. And then we're going to multiply by 100%. And if we do this, we get 15.5% error. One last way we can check to make sure these values, this 15.5% and then on the last slide this 84.5% makes sense, is that they should add up to 100%. Percent yield and percent error kind of on a seesaw. As one goes up, the other goes down, but they're always going to equal 100%. So 84.5 plus 15.5 gives me a total of 100%. So this was percent yield. Again, it shows efficiency, how efficient the reaction went according to expectations. Stay tuned for the next and last video of this stoichiometry web tutorial. It will be on limiting reactants. As always, if you have questions, please feel free to ask before school, after school, during guided study, or even during class. Make sure you're studying for our test tomorrow. Enjoy.